Welcome back. Joining me this morning is Josh Taylor from Discovery Playhouse here in Cape Girardeau, here to show us some fun experiments that we can do that's going to make snow or ice or something like that. What do we got going on?
Thanks so much for having me today.
Of course.
Yeah, so today I'd like to talk a little bit about snow and in particular ice.
Yes.
I know that a lot of us have been feeling the winter chill lately, especially with like the recent snowfall that's been affecting the Cape Girardeau area. So I thought in the spirit of the winter season, we could explore some of the really interesting properties of ice.
Yes.
And how it behaves when it comes into contact with various materials and surfaces.
I love that. Let's get to it.
Yeah, so to do that, I've got a demonstration here laid out for you guys today, and it's going to involve some really common household items that anybody can do, including our viewers. They can follow along and they can do this themselves. I would highly encourage it. And this is a very simple demonstration, and while it's really informative on the properties of ice and the science of thermal science, it's also a really cool demonstration peeking on the key points of the scientific method.
Interesting.
And so when we're doing the scientific method, which is really important when we're doing science, when we're applying the scientific method, what we do is we begin by gathering data in the form of making some basic observations, and then we use those observations to formulate a hypothesis.
Right.
And a hypothesis is, of course, just, we call that an educated guess. And that hypothesis is going to serve as like a model or an explanation or a prediction of some sort of natural phenomenon.
Right.
And so to begin our first observation, what I'm going to do is I'm going to use my first item here, which is just a standard plastic cutting board. You can find this in any household, very common item. And so what I want you to do, if you want to help out, you can actually want to take hold of that cutting board, and we're going to use our sense of touch to kind of get a reading on the temperature of that item. So you want to just place your hand over that cutting board and kind of tell me what you're feeling in terms of temperature. Does it feel very warm? Does it feel very cold? Something in between, like room temperature? What do you think?
I would say it's probably like room temperature. It's not warm, it's not like frigid, but yeah, I would say room temperature.
Great, yeah, so that is the reading we got for the cutting board, and then once again we're going to repeat the process with this item, just a standard stainless steel pan, another very common household item. So once again, you want to just place your hand over that pan and kind of get a feel for that temperature and kind of compare it or contrast it with the cutting board. Would you say that it's rather warmer than the cutting board or colder, or do you think it's roughly the same?
I'd say this is colder.
Colder.
Yeah.
Yeah, that's that's right. Most of the time when we're dealing with these steel and metal cookware, typically they're going to feel a lot cooler to the touch in comparison to our cutting boards here. And so now that we have our observations, we can form our hypothesis.
Okay.
And this hypothesis is meant to answer this question. What's going to happen if I take some ice and I place them on each surface? What's going to happen? Which of these items do you think are going to more efficiently or more effectively melt that ice? Is it going to be the cooler pan, or is it going to be the seemingly warmer cutting board? Which do you think? Which do you think is going to happen?
I would say that this would melt it faster because it's warmer.
Sure, yeah,
right?
that's a really intuitive guess. And that's the thing about hypotheses. We don't need to worry about whether the hypothesis is correct or not, because what matters is the verification process. Putting that hypothesis to the test is what really matters. And so that's where the fun begins. That's where we get to do the experiment. Because at the end of the day, that's what an experiment is all about. Experiments are meant to test those hypotheses and to figure out what information we can glean from them. So I have here 2 ice cubes, and what I'm going to do is just place each one on the surface of each item, and we're going to wait for those to melt a little bit. And it should only take a moment or two, and while we wait for that melting process to do its thing, once again I want to return to that hypothesis that we mentioned, because it's a rather intuitive guess, right? Because ice is cold, in general it's going to melt faster when it's subjected to a warm environment, and melt not as much when it's subjected to a cold environment. So it's rather intuitive to imagine that the cutting board is going to melt it more.
Right.
But we find that when we apply this in reality, we might be a little bit surprised, because we can already see, if we direct our attention back to these items, you can notice already in the short few moments that this ice has been in the pan, you can already see it's melted quite substantially. You can actually see, you can see some water forming at the bottom of the pan, and so it's in the brief amount of time that it's been in there, it's already melting quite substantially in comparison to the warmer or seemingly warmer cutting board. It hasn't melted at all. It's totally dry on there. And so it looks like our hypothesis has been contradicted by the result of the experiment. But that doesn't mean that the experiment was a failure. It just means that we've learned something new. And now we can ask a brand new question. why is this happening?
Yeah, why?
Why is the cooler pan melting the ice faster than the seemingly warmer cutting board? And the answer lies in the pan because it's made of metal. And metal is a really, really effective thermal conductor because metals contain lots and lots of what's called free electrons. And unlike regular electrons, which swirl around atoms, these free electrons are not bound to any atoms. So they can move freely throughout the surface and throughout the material of the metal. And those free electrons are really, really good at efficient energy transfer. And oftentimes that's going to come in the form of electrical energy, which is why electricity passes through metal more effectively than it does through other materials like wood or plastic. But it doesn't have to be just electricity. It can also be really effective at transferring kinetic energy or thermal energy or heat. And so in reality, while this pan did feel cooler to the touch, in reality, these two objects are the same temperature. The only reason why this pan felt cool was because you were experiencing that thermal conductivity in action. What you were feeling was this pan, those free electrons were actually taking the thermal energy, the heat from your hand and pulling it out of your hand and transferring it into the metal of the pan. And we feel that, that reaction as the sensation of cold. And so while it feels cold, it's not actually so. It's just the sensation of that thermic reaction. And because it's such a great thermal conductor, it's drawing all of the temperature out of that ice cube much more effectively than this cutting board, which doesn't have that many free electrons. And so it's actually a very, very poor thermal conductor.
That's amazing. I mean, I feel like my science lessons from back in grade school are really coming back now, but I wouldn't have imagined that. That is super cool, and it's such an easy experiment that you can do at home. We have all of these items at our house. You could do this with your kids, and you could really kind of stump them on this, but then, you know, it's not like they were wrong. It was intuitive, so that was great. Thanks so much for joining us this morning.
Thank you so much for having me.
We'll be back in just a bit.